Good morning, good afternoon, and good evening, everybody. My name is Kartik. I'm one of the co-founders of ETH Global, and I'm super excited to welcome all of you to Scaling Ethereum 2024. You are all watching this on ethglobal.tv. This is what we're going to be using today as an interactive platform to talk to everybody and showcase what came out of this hackathon. You can ask us any questions, you can talk to us, and we get to see all of that live. So looking forward to saying hi to all of you and sharing about all the cool things that came out of the last month. Now, Scaling Ethereum is an event run by ETH Global, and we're an organization with a very simple mission. Our goal is to onboard thousands of developers into the Web3 ecosystem. And we do this by running hackathons and summits, both in person and async. And this whole month was about scaling Ethereum and making sure we get to build things that take advantage of all the infrastructure that we've been able to work on and develop and launch over the last few years. So this is what came out of the hackathon. We had over 830 hackers from 75 different countries, spanning 23 time zones, take the last 3 weeks to build incredible projects that took advantage of different L2s, privacy-preserving technologies, and everything in between. And we got people from all over the world. There's representation from 6 different continents, and you can just see the amount of people that we were able to bring together to build things that matter to all of them. And not only that, we also had 90 ecosystem mentors through our partners and dedicated mentors who were there to help unblock all of the participants to make sure that their projects can come to life without any hassle. And I also want to thank 12 of our incredible partners who made this event really great by bringing on their support and also giving away a lot of prizes. So I want to thank Arbitrum, Avail, Filecoin, Gnosis Chain, Sign Protocol, RIS0, Morph, Neon EVM, Nillion, CurveGrid, Powerloom, and Witness. All of them are giving away a lot of amazing prizes as well, and we're going to get to that very soon. But let's pause for a second and talk about one quick thing before we go into summarizing this whole month. 800 of you participated in this event, and we want to understand what we can do better here. So as part of that, we want to take 60 seconds of your time and have you go to your Hacker dashboard right at the homepage, the second you go onto the event homepage, and fill out the quick survey and the feedback form on how your experience was over the last month. This really helps us improve all the things that we do to make sure that the next 1,000 people that we bring in a few weeks later have a much, much better experience than the people before. And we really want to constantly iterate and improve every aspect of what we do here. So getting that feedback from you will be very, very helpful to us. And as part of that, we're also going to be giving away 5 of these hoodies at random for anybody who fills out the feedback form. So if you want these free hoodies shipped to you anywhere in the world for free, just take 60 seconds and fill out the feedback form. You just have to answer questions that are rating things out of 10, and it should really not take you more than 60 seconds. So we would really appreciate that and hope that you get to help make the lives of the next 10,000 people even better. Now let's get into the hackathon. 833 hackers spent the last 3 weeks building incredible projects. And I'm super glad to say that we had 199 submissions that came out of this event. And after those submissions from this Sunday, 4 days ago or 5 days ago, we had the hard job of facilitating a judging process to get to a list of some of our finalists who we're going to bring on here and have them demo live what they built. So after those submissions and a rigorous judging process, we landed on 8 finalist teams. These teams are going to come on one by one and demo what they built. And without further ado, I'd like to congratulate all of our 8 finalists for scaling Ethereum. So I'm going to give a massive applause to Chainsweep, Sign Kaleidoscope, Block Fusion, Monetic DNA, Forge Flame Graphs, Create Toolbelt, Ethereum Localization Service, and TX Fusion. These are the 8 teams that are going to come on and show you what they built and really demonstrate how they managed to help take advantage of all the tooling and the cool things that we can see given the infrastructure we've had in the space over the last few years. And before we bring on these teams, I want to take a quick second to thank every team that's listed here who participated and submitted a project. Just because you were not one of the 8 teams does not mean you were not good enough or there was something wrong. The finalists are a way for us to showcase some really interesting themes and patterns that our judges really liked. And I want to make sure that you do not feel discouraged for not being chosen a finalist. You still spent weeks building something that you were passionate about, and I really hope that you get to continue building that same project after the event ends and not just stop there. Our job here is to make sure that we get to facilitate this for you. And what that means, if you are looking for any sort of help, whether it's introductions, resources, connections to anybody in the space, anybody within a network is fully open for you to reach out, and we will help facilitate that network and make sure that you get to the place where you want to be and continue building in this space. So we really hope that you are proud of what you built, and not to worry, there's a lot of you who won a lot of prizes, and you'll soon be able to find out what you won as a prize, and we'll announce that very soon. All the projects that came out of this hackathon are listed on our showcase page, so you can just head over to ethglobal.com/showcase and see the full list of 199 projects. So with that, I'm going to stop talking, and we're going to bring on our first finalist demo for the day. And let's give a massive round of applause to Monetic DNA.
Thanks, Karthik. Hello, everyone. We're Monetic DNA, and welcome to our demo. Our team is based across North America, Africa, Asia, across multiple countries. And we've been working around the clock on this project, so we're really proud of what we built. Something that we're really concerned about for a long time is how beneficial personal genomics can be. Services like 23andMe and Ancestry.com can be so useful, but the data is really not secure. There have been multiple breaches. People don't have access to their own data often. So with the new technology that's available to us in this hackathon, we've been trying to show a new way to do it in a privacy-preserving way. So this is our portal. This is the linchpin of the entire ecosystem. So you show up here, and you use this to onboard yourself. So you can bring your existing data. So this is my own data from 23andMe. This consists of my DNA information. And I come here to create a DNA passport. Now, select bits of the data, the relevant bits, are taken and they're stored as secrets on the Nillion network. And it's really cool because this data is completely private. No one can look at it, no third party. And when we perform computations on the data to assess disease risk and things like that, it happens on the encrypted data. Like the data is never decrypted, unlike 23andMe and other services like that. So great, we have our DNA passport. I'm gonna save it here. All right, that's with 905. So we also built some example services that show the power of this paradigm. So this is SnipperBot. SnipperBot operates on DNA information on the cloud. So I upload my DNA passport, which has all the metadata and information needed for SnipperBot to be able to run these computations. And as you can see, the computation from the Nillion network that was on the secret data performed confidentially is back. I have low risk for thrombophilia, and I'm really happy about that. Another service we have is called EmptyDog. EmptyDog uses RISC-0, which is a verifiable computing platform. And you install a program locally on your computer. I've already installed the program. You provide it with your information, with your genetic information and your passport once again. Here, I'm running a computation on the network. So it's actively analyzing my DNA on my computer. And just to be clear, here the data is local, is unencrypted in order to run more intensive computations. I have the option of writing my results on chain. And one thing I want to point out is there is a chain of trust using sign protocol that's been established. So Monadic DNA attests on chain which providers are trusted. And it also attests when it receives user data, which data sets are complete and trusted. And each result that we find on any of these services, they're all written on chain as attestations, thereby completing a chain of trust. So let's go back to the Monadic DNA portal right now. And what we can do is, now that we use some services, we can view our results. So here we view our results in a consolidated manner. So I'm going to upload my DNA passport. And yeah, you can see the results from the different applications came back. It reiterates that I have high risk for type 2 diabetes. Fortunately, low risk for thrombosis, so that's good. So as you can see, these are attestations written on chain. These can be displayed as neat PDFs in the future that detail everything for healthcare providers that can independently verify all the computations that happen. So there's trust while still maintaining privacy. So that's really cool. And again, this is my own data stored in secret on the Nillion network. All the computations were done on secret data, unlike 23andMe and other services. And with RISC-0, we use verifiable computations, so everyone can have trust that the computations ran successfully, even though privacy was maintained. And in the future, we're going to add payments to all these services to set up the correct incentives. We're going to be dealing with larger data sets to perform more advanced analysis as the platforms become more scaled. We're going to partner with DNA labs, so we have end-to-end genomic privacy. And finally, we're going to add more traits. Anyway, it's been a pleasure. Thank you all very much. And please definitely try this on your own. Find out more about our company, Cryptonomic, and see you all online. Thank you.
Amazing. Well, thank you so much for being the first mindless demo. And it was awesome to see not only this work on your own live data, but actually showing a real application of a privacy-focused tech that actually helps solve a really important problem. So congratulations, and we hope to see a lot more feature detections in the future versions of this.
Thanks, Karthik.
Amazing. All right, with that, we're going to get ready for our second finalist demo, and that is Team Sign Kaleidoscope. So Daryl and Jane, welcome.
Thanks, Kartik. Hey, Global. I'm Daryl, and I'm here with my teammate Jane, and we made an Explorer for Sign Protocol with an interactive graph visualization. So Sign Protocol lets you make on-chain attestations according to schemas stored across the decentralized web. These are the most popular schemas according to SignScan. We've got a good mix of on-chain and off-chain locations, Arweave, IPFS, Base, Polygon, etc. And as you can see, if I click on one of these edges, we see that attestations are represented in this graph as sets of directed edges. So for example, for this particular attestation, you can see an edge coming from the attester node to the schema stored in Polygon, and a few edges corresponding to the schema nodes of the recipients of the attestation. So I can click around and even hover over these to see more details about all of the entities at play. Here's another example over here. This was from a Farcaster Frame contest last week where people tried to guess what the price of Bitcoin would be at the time of the halving by issuing a attestation on their own account. So you see for this attestation, there's a edge coming from the account to the schema node and back to their own account to show that it's a self-attestation, and it sort of looks like a daisy. I thought that was pretty cool. I'll continue to click around, but I'll hand it over to Jane to talk about the motivation behind our idea.
Yeah. So when we were starting brainstorming on the idea that we can build for this hackathon, one of the problem that we immediately think of is, so through a lot of attestation services are live on the Ethereum network right now, which allows various kind of data to be able to store it on chain, or to be thrown on chain and stored off chain. That nowadays that we only have products such as eScan to allowing all the users, those people without technical background, to be able to see all those records line by line, which so we want to create this data visualization place for people to be easily seeing all the attestations stored on chain. And of course, this method can also be applied not just to attestations, but also all sorts of data that is stored on chain, whether it's in the format of NFT or other kind of ERC that are stored on the Ethereum. So yeah, that's basically our motivation behind why we're creating Sign Kaleidoscope to letting users better seeing all those data stored on chain.
And here you have it, folks. It'll take a while to kind of settle, but here we have the Web of Trust according to the users of Sign Protocol. I flipped the switch earlier to make the data live faster. And that's basically the project. So let me talk about the tech stack real quick. I use the SignScan API for querying schemas and attestations, a library called Graphology for modeling nodes and edges, Sigma.js for rendering the entire visualization to WebGL on the web front end, and of course, SvelteKit for the URL routing and data loading logic, and finally, Svelte 5 Preview as the front-end framework. I highly recommend Svelte. I've used it for all my personal projects. It's lightweight, super performant, and it's a superset of the web standards that you already know and love, HTML, CSS, and JavaScript. And the new Rune syntax, which is about to be introduced in Svelte 5 in the next month, will let you define reactive JavaScript variables. So you can granularly recalculate intermediate data calculations used throughout your app without having to manually specify your dependencies. So fellow front-end devs out there, consider this your science. You perhaps learn a new framework and help contribute to what I call client-side diversity. So let's talk about what's next for Sign Kaleidoscope. 3 years ago, I was actually a finalist at ETH Global Hack Money 2021, where I built a block explorer and DeFi protocol or DeFi portfolio tracking app called Blockhead. And dozens of hackathons later, I've since expanded it to include explorers for a bunch of networks and protocols across the entire decentralized web. So my next plan is to upgrade the existing visualizations here and even add new ones using everything I've just learned about syncing graph visualizations to SvelteKit URLs, and eventually turn Blockhead into the ultimate explorer for the decentralized web, which is this beautiful, composable, interoperable web of trust that you all are helping make a reality, and I feel deserves to be seen for the technological marvel that it is. You can read more about the project on my Gitcoin grants page, where I'll actually be accepting $1 donations on Arbitrum for the next 2 weeks. There's a hackathon alumni round that you can support me there. And that's it. If you'd like to keep up with what Jane and I are building, definitely give me and Jane a follow on Twitter and Farcaster. Thanks all for tuning in.
Awesome. Well, that was a great demo on just actually visually being able to see this. And I feel like one obvious thing here is that we actually get to see better ways of visualizing data. So the fact that you're actually continuing to do this thing and we can do a better Block Explorer is a great theme for us to build on top of. And not only that, I actually want to thank you for continuing to build Blockhead from years on. And this is the right spirit of actually building something that you are really passionate about. So congratulations.
Thanks, Kartik. It's been an honor.
All right. With this, we are ready for our third finalist demo, and that is Ethereum localization service. So, Vincent, welcome. There we go.
Hey, thank you, Kartik. Yeah. Hi, everyone. So I've been to multiple ETH Global Hackathon, and I always ask the local, what is the best rack? So in Tokyo, it's a potato chipuzu no tame no ohashi. Yeah. And in Paris, it's a pes foncé pour le café. So you might feel missing out and you want some translations, right? But that's the daily experience of 6 billion of people, because only 70% of the population are speaking like English. And they are missing out on Ethereum because most of our content is also in English. So how could we help them? So I've been talking to multiple communities, and in the case of like Ethereum.org, they actually double their audience by translating their website onto multiple languages. But some of the other communities, they are facing a lot of the challenges. So on the technical side, many of them are not familiar with the localization workflow, and the access to AI is limited to like biased and centralized providers. And for some of the other like languages, they don't have enough resource to change their model. So there's a need of human in the loop decentralized AI models. And then on the other hand, on the community side, many of them do not have enough budget, and they try to put up crowdsourcing. But then like YouTube or Twitter, they shut down their platform because of abuse. Also, we will need to retain the contributors by giving them rewards. So there's a need of trustless incentives and attestation mechanisms. And these are the motivation we are building Ethereum localization service, a decentralized translation incentive network with AI and human attesters. So last week, I was binge watching this like Padma Denver playlist. It's awesome. So let me demo by translating this playlist into multiple languages. How it works, in our AI pipeline, we will download the videos from YouTube and then extract the audio, turn it into a spectrogram, and then put it onto like ASR module, automatic speech recognition module, like Whisper from OpenAI. Then we can get the subtitles from the original language, and we use Lighthouse to put them onto IPFS and mirror them onto our translation management systems. Now we can use centralized or like a modernized AI services to translate them into multiple languages, or we can also run our own open source model on top of decentralized frameworks. So let me quickly show you. This is the COM extension we built. So in this COM extension, you can see the translated subtitles is side by side with the original video. So we can have like multiple languages for this video and then understand what is this about. And more importantly, we are able to like gather the feedback from the end user. So I can like fold up or fold down the translation in a fashion very similar to the like a Stack Overflow. And more than that, I can actually just submit some translation suggestion onto it, which will end up in our translation management systems for people to vote for the best. And here the attestation is based on the Ethereum attestation service. So let's go back to our architecture a little bit. So besides the Chrome extension to render the subtitles and create attestations, we know many communities need the budget. So we also integrated the grant stack for the grant portal. So here we have the grant stack such that you can crowdfund for your localization effort, not only like crowdfunding the crowdsourcing your translation, but also crowdfunding. And then eventually reward to the contributors, no matter it's an AI agent or a human attesters. And we also have like created a customized strategy, a smart contract on the Allo protocol, which will verify our contribution allocation using EAS. So our contribution will be derived from the commitment and the translation time using social grants and commit that on chain, such that the final fund is able to be allocated to recipients in a trustless and decentralized, secure manner with our protocol. So I believe we can create a regenerative data DAO model, so we can incentivize more attestations, create smarter AI, better translation, bigger community, and finally create more incentives, and we go again. So I'm building this as a public good project, and we will need your help. So follow us on Twitter, XL10N, and we are also on this one's GitCon. Yeah. So thank you everyone, no matter where you are. So merci beaucoup, vielen Dank, 謝謝大家，感恩多謝晒，ごまwo，ありがとうございました。Thank you.
Thank you. This was awesome and such a good practical way to think about making this a useful thing using crypto. I am super happy to see this work, and congratulations for making such a useful utility. I am more than happy to say that ETH Global would love to use this as soon as it's ready, and we'll start with the Pragma Denver videos. So congratulations, and I hope to see this thing again. All right, with that, we are ready for our next demo, and that is Transaction Fusion. So let's welcome Transaction Fusion team to the stage. Whenever you're ready.
Hello, Karthik. Hello, everyone. This is Transaction Fusion, a platform allowing users to perform multiple transactions in a single call and a signature using the new EIP 5792. Let's look at the problem we're trying to solve first. So users have to juggle across different DeFi platforms like Uniswap, Compound, and Aave to perform DeFi actions, which is complex and time-consuming and resulting into a bad UX. This is not just limited to DeFi space, but it can be also seen in other spaces like NFT and auctions. So here is the solution. We built a unified platform for DeFi transaction simplification, where you can execute multiple transactions across different protocols like Uniswap, Compound, and Aave. We support EIP 5792 and use wallet sends call method to create batch of transactions and send them to the connected wallet. Lastly, we also allow our users to create custom batch of transactions independently, offering them flexibility and control over their activities. Here's how we built it. As a user, you will interact with an application where you can choose from the presented batch transaction examples, or you can create one on your own. The app will then create multiple calls in this format by taking the basic transaction data and then use the wallet send call method to send them to the wallet. Wallet should be able to recognize the type of account and create the signature for the type of operation. So for example, if it's an EOA, they have to use in the Nubian discussion EIP 3074 to get the user signature and then send it to the invoker. Similarly, for EIP 4337, they have to create a user operation and then get it signed by the user's owner of the smart contract wallet and then send it to the bundler for further execution on chain. This is how you will be able to interact with all of these DeFi protocols. So it's finally demo time. Let's go to the website. This is our website where we have a few examples which you can choose from. So you can swap native assets to tokens on Uniswap, which will do 3 actions. First of all, it will deposit ETH to the VETH contract, and it will approve the VETH to Uniswap router, and then swap VETH for VETH token on Uniswap, all in a single transaction. Furthermore, you can borrow against a supplied collateral token from Aave. This will approve, supply, and borrow all-in-one transactions. So now you can imagine how improvement of a UX is this. This is from the current UX you have to go through. You can also earn yield by supplying it to the Comet Wedge pool using compound finance. And then you can also interact with a custom contract, which is to just show the power of how multiple batch transactions can be used, where we mint NFTs, burn, and transfer them. So now let's actually look at one of them. I'm going to swap these native assets. We'll select the token and the chain, which is limited to base Euphoria for now. And we will enter the amount to transact and hit execute. This will ask for a smart contract wallet signature. So we'll just go ahead and do that. This has been done by the Coinbase Smart Wallet SDK currently. So as soon as I do that, it's done. The transaction is submitted, and you will see a link of the same here. So you can see that the 0.05 ETH was transferred from my account to the Wedge contract, and it was also approved in the same transaction, and then it was swapped on Uniswap router for the BAT token. So it was that simple. Now we also allow users to create their own action, so they can go ahead and select the chain which they want to interact with, and then select the protocol. Then they have to enter the address. So we have this demo contract which we are going to use for the demo. I'm just going to enter the address, then the API which I want to interact with, and this will load up all the functions which are available. So I'm going to hit save mint, and then we can add the wallet you want to mint the token for. So I'm just going to mint it to my same wallet, and we'll add another transaction where we'll just copy over the same contract and the same API and select a new function which will be safe transfer from. We'll transfer the NFT from my account to my another wallet, and we'll hit create action. This will be again a signature using my passkeys. So we'll confirm that, and it's done again, and we will see a transaction link on Basecamp. So it was minted and then transferred in the same transaction. That's how it improves the UX. We got inspiration from Jake Som's tweet and a reference from Wilson and Lucas EIP 5792 demo. And we also want to thank them for the Coinbase and VM team for adding support for 5792. This is the team, and I'm Dhruv. Thank you for your time.
All right. Well, congratulations. And that was a super badass demo. You get to kind of just do a lot of these bulk transactions, and definitely a better approach than kind of the multi-call architectures that we have now. So thank you for actually implementing a cool EIP, and hopefully this becomes a much bigger standard. Congrats.
We hope so. Yeah. Thanks a lot.
There we go. All right. Next up, we have Forge Flame Graphs, our 5th finalist demo for today. So let's welcome all of them here whenever you're ready.
I'm Soham, and I'm here with Saurav, Meet, and Himang, and we are team Forge Flame Graphs. Flame graphs are traditionally used to find performance bottlenecks in C, C++, Rust code. So the x-axis here represents the serially called functions, and y-axis represents the functions that are calling other functions. And we have a function called trace. Why do we need flame graphs for celerity? An engineer who is wanting to optimize celerity code ideally should start looking at the part of the code specifically which is responsible for most cache consumption. However, it takes time to guess from where to start, and a lot of skills are also needed. Our project is a Foundry plugin. It takes the debug traces from Foundry and source maps and passes them into internal functions called tree, and then converts that into a flame graph SVG. Let's forge some flame graphs. Here I have a Poseidon 2 hash function implemented in Solidity, and let's just go ahead and generate a flame graph for this. So I have this command where forge flame graph, and I'm passing a test function here and a debug trace flag, and it will open this, it will generate a flame graph and open it in my browser locally. So the flame graph is generated. And here we can see the internal functions that are being called in the function. and also if there are any S-loads or S-stores involved. And if we hover on any of the functions, then we can also see the gas cost that is associated with it and a percentage value of the gas consumed in terms of the entire call. If we click on any of this boxes, then it expands, and we can more clearly see how this functions are. And there are also some gaps, and these gaps represent the inline solidity logic. So if I go a bit back, and we can see a lot of stuff that is happening inside the permutation function here. So one after the other, a lot of functions are being called, and we can also see multiple functions are being called repeatedly. It would be great to see like a mix of values which a particular function calls. Like if sbox is called multiple times, so how much sbox collectively consumes the gas. So I'll go back to the terminal and I'll just include a merge flag. So this merge flag will mix all these same function calls and give us a common value. So the updated flame graph is generated. And if I zoom it a bit, here we can clearly see that the internal M multiplication function is called multiple times, and collectively it consumes it consumes about 123k gas. It's about more than 50%. And from this view, it's clear that if we want to start optimization of our smart contract, so this is the function which we should be starting from. So I'll head back to the code. So this is the function which is costing most of the gas. So I'll just do the optimization. So the optimization is done. And now let us generate the flame graphs again. So the updated flame graph is generated. And if I hover on the internal multiplication now, so it now consumes 48k gas. And just to recall, in the previous case, it was consuming about 123k gas. So we have done over a half optimization, and we can exactly quantify how much optimization that we have done for this specific function. And just to sum this up, flame graphs help gas optimizers to be better at their gas optimizations. Thanks.
Super cool. Well, thanks for that demo. And I think the best part here is that you get to actually make this work directly with your existing Fort setup, if I understood it right. And
yeah,
that's just super convenient because you actually now have better debugging tools and also visual to a debugging tool. So this is super cool, and hopefully all of us get to try this out. So congratulations.
thanks.
All right, 3 more finalist demo to go. So without further ado, let's welcome Create Toolbelt.
Hello. Okay, let's go. Sorry.
There we go.
Okay, let's start. Hello, hackers. Welcome to our presentation. We are Eugenio and Victor. Today, we are excited to showcase our project, Create Toolbelt. It's a set of smart contracts that will help you on complex deployments. So let's take a quick look of what we will be covering today. First, we're gonna do a quick review of how the contract address deployment works. Then we're gonna show you the Create2 opcode, the Create2 deployer, and what we have been building, the Create3 deployer. And last but not least, we're gonna be doing a simple demo that we have built to showcase what's the Create3 deployer. So let's start. Every contract has a unique address, okay? Usually it's determined by the address of the deployer and the nonce. What's the issue with this? If you want to do a multi-deployment on different networks and you want to use the same address, it's pretty difficult because you have to have the same nonce. So the solution for that is using the Create2. The Create2 lets you deploying an address using the deploying on an address, and it's going to be determined. The address is going to be determined by the address of the deployment. That's a contract, the salt, and the hash of the bytecode. So this is usually used in complex deployments. So there is like this global contract that is deployed on every network, and it was deployed using a method. It's called link method that lets you sign a transaction without knowing the private key. So you just have to send some money to the address and replay the transaction, and you got this contract. This is like the default. This is like a setup from Foundry. So we could assume that that's in every places. So there is another flavor of the grade 2 that lets you use the first 20 bytes of the salt to set your address, so nobody can front run you in case that you will be deploying an init creation code that has some takes origin, for example. Okay, so let's now review the grade 3 pattern and what we have been building. The grade 3 pattern basically is using the grade 2 and the grade. Mainly, it's used the grade 2 to deploy a proxy, and this proxy will be deploying the address using a grade. So your address will be determined by the deployer address and the salt that you have chose, and know the bytecode. So we have in this hackathon we have upgraded the grade 2 factory, and we have shortened it using half. This is like the output. How do you see it? If you want to take a quick look into this, you could use the GitHub. Our final combination is the grade 3 deployer, and this is what we have built. And I want to showcase how does this work. Just for a quick recap, this is the GitHub, and we have deployed multiple networks. And if you want to deploy this on your network, it's going to be deployed on this address, and it's impossible to change that unless you change the salt, of course. So I have built this simple like hackathon example. It will let you mint an NFT that's been binded to an address. So let's do assault here. Let's choose assault, for example, for 2069. So I'm using here a commit reveal scheme. This is mainly to avoid any kind of front run issue. So if you do this, so okay, first we need to commit. This is gonna be sending a hash of the salt and my message address, and then I'm gonna be clicking on the mint. First, we have to wait until this transaction is done. Okay, it's done. So now we can click on the mint. Sorry, sometimes takes some time to work. Let's click again. Come on. Okay, it's doing multiple times. Sorry. Okay, let's close this one. Let's use this one. Let's click again. Sorry, network issues. Please bear with me. Come on, MetaMask. Okay, it's on. So we're gonna click here. Let's do an aggressive, so it's minted right away. Meanwhile, we could see the transaction. So this is gonna be minting an NFT. I could send this NFT to anyone, and he will be able to deploy on this address. Okay, let's remember this address. So for this case, I'm gonna be deploying the wet contract, that is this one. So I have to copy the creation code. You could do this with any contract, or you could build it on Forge and just send it. Okay, so we got the NFT. Now let's gonna be deploying the contract. So I have to enter the bytecode. And one important thing is here is it's an X, so I have to put 0x. Frontend is not like the best thing that we have done. It's just something functional to work. You could play it around with if you want it. So again, let's gonna confirm this. Okay. Now this is gonna be minting the wet contract on this address. So let's copy this address to see that I'm not lying. This address right now has nothing. Let's see the transaction. We have to, okay, it's ready. Let's take a quick look on the transaction and how does it look. So this is going to be burning my NFT to avoid anyone to reuse it, and it's going to be deploying the web contract on this on this address. So this on this address. Okay, if you pay attention, now it's got this address T2. As you see T2 here, it has the Web9 contract. And if we take a look to the transaction debug, we're going to be seeing that it's going to be deploying a contract. It's going to be the one that deployed the Web9. It's going to be doing a self-destruct, and it's going to be burning the NFT. So that's all. I hope you have understand it. And yeah, thanks.
Amazing. I know that was a heavy DevTool based demo, but this is such a creative and a cool way to think about making everything compatible when we have so many chains, and we're already getting to that world. So this is such a cool utility, and hopefully this becomes a much easier way to kind of deploy and create new standard contracts that have the same address. So congratulations.
Last thing, please take a look to the GitHub, because there are many examples of how to use it there. So thank you.
Even better. So congratulations, and we hope to use this thing soon. All right, 2 more finalist demos to go. So without further ado, let's welcome Mark from Blob Fusion.
Hi there. Can you hear me already?
Yes, we can. Whenever you're ready.
All right. Yeah. Hi, my name is Mark. And this scaling Ethereum, I've created a project called Blob Fusion, which is making blob space affordable for everyone. So what's the context? About a month ago, EIP 4844 was introduced, which was all about scaling Ethereum. And it also got us blobs, which is a new way to store data on Ethereum that is ephemeral, which means it's only stored for 2 weeks. And because it's not stored for such a long time, it's super cheap. But there's one big problem, and that's that you can only post full blobs. So if you have, for example, only 25 kilobytes of data, you still have to pay for the whole 128 kilobytes, which is of course not optimal. This means you have to pay much more. And that's actually the reality we're currently in. Like the average blob size, this is a screenshot from BlobScan, is 25 kilobytes, which means that on average, we are overpaying by 500%. But there's a solution, and that solution is not BlobScan, Blob Fusion. And you can think of Blob Fusion as ride sharing for blobs. So instead of everyone buying a bus and going from A to B with this bus, you can just, like, I can buy the bus and you can hop onto mine. And this is much cheaper and also much more environmentally friendly, which is also true for Ethereum. So let's check it out. This is the interface of Blob Fusion. And the first thing we need to do is to add some funds. Like there are already some funds here, but for the sake of it, let's just add some more, and it should quickly get updated. And here on the left, we see the contents of the mempool, which are the unfused blobs. And on the right side, we see the blobs that are already on Ethereum. So the first thing we need to do is to create a new blob. And for that, we can just use this magic button to create some lorem cryptum. And then we have to bid for it, which is to say, how much do I want to pay for this blob to get included? And luckily, we already know how much a full blob will cost, and we want to include 2 blobs. So let's just use that one and add some more, make really sure that it's included. And you can pay more to get included earlier and pay less, but then you maybe get included later. And then we have first have to sign it to prove that this data is ours. And then a new blob gets created, and let's quickly create another blob with a similarly high bid. And in theory, those 2 bids should be enough, to create a new blob. So that's what just happened here. So this blob is now sent to the network, which is currently Sepolia. So let's click here on BlobScan. I quickly also click on another one that's already included. So, all right, let's use the older one. And when we click on this one, we see the merge blob. So we have this ipsum here, and then some jumbled mess here, which is the signature and also saying how much, how long this blob is basically. But of course, Blob Fusion that's a lot of magic that's going under the hood. Like, it's a very deeply technical project. So let's check out how it actually works. And we have the front end here, React app, backend, and Express app. And then we have two networks that we're interacting with. And the first thing we did was to deposit some ETH to Arbitrum, a smart contract on Arbitrum. And we chose Arbitrum because transaction fees are much lower. So the overhead to post a blob is also lower. And then we have the network event listener that waits for ETH to be deposited and updates the balance for the user. And then we can send a partial blob, and it gets added to the mempool, which is here in Postgres. And the scheduler is it's responsible for building blobs, and it tries to build the most optimal blob it can. And an optimal blob is one that is as full as possible, and where each bit is higher than what the partial blob costs. And then, of course, the sum of all bits also needs to be higher than the actual cost. And then we send it through Ethereum, or Sepolia in this case, and update the actual costs that got incurred on the network and updated in the database. And there are two interesting questions to go into. And the first is, how do we price those partial blobs? Like, one idea could be to just price them relatively. So if you use 20% of the space, you pay 20% of the price of the whole blob. But smaller blobs actually have more value than bigger blobs of using blob fusion. So I think we should price them higher. And then the other interesting question is how to fuse those blobs. Because fusing blobs is an instance of the bin packing problem, which is actually NP hard. And NP hard means super hard, exponential time. So that would be interesting to go into. And we actually have a nice idea that might work quite well here, but it's of course not solving NP hard, an NP hard problem. So yeah, that's blob fusion. It makes blob space affordable for everyone by utilizing blob space optimally, and thus lowering transaction costs and scaling layer 2s and Ethereum to the next billion users. And because of that, you can not only say it makes it affordable for everyone, it's actually scaling Ethereum in 2024 and beyond. So that's it with blob fusion, and I give it back to the team.
Amazing. Thank you. And congrats on making such a cool utility. I think this is just a super practical way to think about how do we actually save storage and actually reduce the cost for everybody. So hopefully more people get to use this thing live. Congrats.
Yeah. Thank you.
All right. With that, we are ready for our last finalist demo of the day. So without further ado, let's welcome Chain Sweep.
Okay. Hi, I'm Matthijs, and I will present my hack for this hackathon called Chain Sweep. Chain Sweep is basically Minesweeper on chain, and I can show that best by showing a demo. So I think everybody knows the game Minesweeper, right? You have a field of squares, and under some of those squares, there's something bad. I mean, Minesweeper is a mine. In my Chain Sweep, it's a buggy block. So let's open some of these fields and see what happens. Okay, and so yeah, if you open a field that is not a bug, then you get information about how many bugs are around that field. And if you think about this game, then the traditional way to implement it would be like the computer picks a bunch of squares where there are bugs, and then you start playing, and then and maybe you win, maybe you don't. But on chain, I was thinking about if you would make a smart contract that does it that way, then because everything's public on chain, it would probably be really easy to cheat, because with the block explorer, so you can just see where the smart contract chose to put the bugs, and then it's no fun. So I thought about how can we solve that. It's kind of an exciting game. It's unclear where those bugs are, but it's still fully on chain without some centralized party. So what I did is I made the smart contract only store the revealed information so far. So the smart contract now knows what I opened, and when I click another field, it will simulate all possible ways that the bugs are distributed in the remaining squares. And I made it also possible to view in the front end. So here we can see a couple of simulations that are consistent with my game so far. And so when I click, then it will pick one of those simulations based on the block timestamp and the gas limit as a random seed. and use that to determine whether I win or lose. So you can see that this square is guaranteed to have a bug based on the information so far. So I will always lose if I click there. But some of the other ones are a bit more unclear. Well, it seems there's no one that is guaranteed to be empty. Let's give it a try. And so every move is then a blockchain transaction. It runs the simulation, and we got a bug and we lost. So, and then you can start a new game and start all over. Try to win this time. At the bottom, you can also see who else is playing. Yeah, this is me, some earlier game, and it's live on Stylus testnet. So anybody who has some testnet ETH can try it. So a little bit more about the technology. It's based on I made the smart contract in Arbitrum from Stylus, and that was really excellent. The efficiency of Rust that gets then compiled to WebAssembly that made this simulation process possible. It would be way too much gas if it were running on Solidity on a traditional EVM, I think. And but with Rust and WebAssembly, it works just nicely. And the front end was TypeScript Vue and Nuxt. And for future improvements, I didn't get to it, but this game is not really that much fun if you have to click that confirmation for every move you make. And I was thinking about making some kind of per game shared secret with then a server process that then fires off the transactions for you. And it would be cool if you get an NFT when you win and it collects those in an on-chain Hall of Fame. But for this hack, I just implemented the basic gameplay the way I described. So whoever wants to play can try it. And I had a lot of fun implementing this. And thank you very much.
Awesome. Well, that was a super cool demo, and glad to see actually a good way to actually play a game that has private information, but all done entirely on chain through kind of the use of the latest tools. So this is super fun, and maybe as a future suggestions, let's kind of do tournaments that people can actually play and enter. So I feel like that's going to be a cool thing to see on chain.
Yeah, that would be cool.
All right. Well, thank you so much, Matthias, and congratulations to all of our 8 finalists. So I want to thank again ChainSweep, Block Fusion, Forge Flame Graphs, Ethereum Localization Service, Sign Kaleidoscope, Monadic DNA, Create Toolbelt, and Transaction Fusion. Now, all of these projects and everything else is also now published on our showcase page. So you get to see everything by heading over to ethglobal.com/showcase. And now the part that I know all of you have been waiting for, let's get into all the prizes from this event. We're going to start off by talking about the $100,000 in prizes we're giving away, and the first one is going to be Arbitrum. So the best Stylus project goes to Stylus Hook for $4,000, and ChainSweep is the second place winner, taking home $2,000. So congratulations. Then we have Sketch Stylus winning the best use of Arbitrum and the best infrastructure project for $4,000, and Stylus Hook is the second place winner for $2,000. The best DSOC project goes to Frame Ecom for $2,000, and ZK Warden is the $1,000 second place winner. And the most original project is Bags for $1,500 and AdLink for $500. And last but not least, so many people worked on Arbitrum, so these 73 teams are going to be splitting the pool prize. And because of the number of teams, they're all going to be splitting the amount equally. So each of these teams get $41.10 each. Next up is Avail. The best app chain project built on Avail DA is ZK Proof Portal and Blob Merger. Both of these teams are going to win $1,000. Then AdLink, Proof of Location, Quasar, and ReturnX are the best apps deployed on Avail-powered rollups, and they're taking home $500 each. So congratulations. Then we have Filecoin. Wasm IPFS serverless is the first place winner for the best decentralized app on Filecoin, taking home $2,500. And FunPoint is the second place winner for $1,500. And Zenock 11 is the third place $1,000 winner. Then Complace, Phil CRM, ETH Garage, Handshake, and Ethereum Localization Service are the runner-ups for the same best decentralized app, and all of them are going to be taking home $500 each. Then the most meaningful use of IPC goes to Telepathy for $2,500 and Open Analyze for $1,500 as second place. And Project Survivor is the third place $1,000 winner. So congratulations. Then we have Gnosis Chain. Kip Wallet is the best consumer-focused app for Web3 users, and they're going to be taking home $2,000. Gnosis Lounge is the second place $1,500 winner, and Sage Wallet is the third place $1,000 winner. Hard to Find is the best Farcaster Lens or dApp with Fileverse integration winner for $1,000, and RoboSaver and DeFi Balance Booster are going to be taking home $1,000 for building a cool integration with Gnosis Pay. Then we have the best developer tool integration category, and Forge Flame Graphs and No Code Soul are going to be taking home $750 each. and for the best cross-chain application using Hashi XTF, and NextPay are going to be receiving $1,000 each. So congratulations. Next up, we have Sign Protocol. Scientify is the best overall project for Sign Protocol, taking home $2,200. Monadic DNA is the second place winner for $1,800, and a Testcaster is the third place $1,500 winner. Then Sign Kaleidoscope is taking home $1,200 for fourth place, and Certify 8 for Moodle is the fifth place $1,000 recipient. Then for the technical excellence category, Scientify again takes home $1,400 as first place, and eCourt is the second place $1,100 winner. Delegate is going to be the third place $900 winner, and IPme is the fourth place $700 winner. For the best UX, Sign Kaleidoscope takes it home with $1,400. Endorse 3 is the second place $1,100 winner. Supply Trace is the $900 third place winner, and a Testcaster is going to be taking home $700. The most creative use case goes to Monadic DNA for $1,400. Certify 8 for Moodle is the second place $1,100 winner. Promptless is the $900 third place winner, and Marry Me is the fourth place $700 winner. So congratulations to all the teams for using Sign Protocol and having some of them win multiple prizes. That's awesome. Next up, we have Risk Zero, and Thumper, Calibri, ZK POAP Communities, and Z0 Wallet are all winners of the coprocessor prize, winning $1,250 each. And then Odisec and Monadic DNA and ZK Aura are the best ZK-EVM applications, and they're going to be taking home $1,000 each. So congratulations. And last but not least, BuildFi, EasyKey, and ZK Biometric are the best on-chain identity bounty winners, and they're going to be taking home $666.67 each. Then we have Morph, and Nectar Finance is the best consumer-centric app on Morph, taking home $2,000. And No Code Soul is the innovation track winner, taking home $2,000. And then Quasar, FunPoint, and OmniChain Deployer are the runner-ups, and they're going to be splitting $1,000 each equally. Then we have Neon EVM. In the best use case of Neon EVM goes to Proof of Testimonial, and you're going to be taking home $1,500. ETH Garage is the second place winner for $1,000, and Lucky Draw is going to be taking home $500. And Neon Pay is the best use of Neon Transfer SDK prize, and you're going to be winning $1,000. So congratulations. Then we have Nillion. PrivyCal is the best application integrating Nillion's tech, and you're going to be winning $2,000. And Monadic DNA and Battleship X are the two novel use cases for blind computation, and you're going to be taking home $1,500 each. So congratulations. Then we have Powerloom. PowerProbe is the best use of Powerloom winner, and you will win $1,000. And now we have CurveGrid. Sage Wallet is the best use of CurveGrid, winning $500. Scientify is the second place $300 winner, and Address Me is the third place $200 winner. Then we have Witness. The best use of Witness goes to Samsar.gg and Znock11, and you're going to be taking home $500 each. And those are all of our prizes. You can see all of them on our showcase page. And if you are watching this live stream late, not to worry, you get to see which prizes you've won on your hacker dashboard or just directly going onto your project page. So before we kind of wrap up, just a quick note on a couple of things. A note on prize delivery is that everything we just announced is tentative and not final, which means that we'll be verifying all code bases before sending all the prizes. And that means if somebody gets disqualified or we find some cases of cheating, that may change the prize or the amounts. So all that will take a few weeks, and our timeline to deliver all the prizes is May 17th. There are some KYC compliance requirements for some of the prizes based on the sponsor. So we'll reach out to you separately if you are in one of those categories, but it'll take the next 2.5 weeks for you to receive all the prizes. Now, before we wrap up, we want to say a couple of thank yous to everybody for making this event really, really successful and just possible. I want to start off with thanking all the people that were involved. And first of all, I want to thank all of you hackers, all 830 of you who spent the last 3 weeks with us building something that you were passionate about. So thank you so much for taking the time and building something that's super cool and also taking home a lot of prizes. I want to thank all of our judges who spent hours talking to all the teams, watching their demos, giving them feedback, and helping make these projects even more successful by giving their thoughts. So many mentors and volunteers that helped out behind the scenes to make sure that all of their work and you are successful in making sure you were never blocked. So I want to thank all the volunteers here. And to all of our speakers who did a lot of workshops, and all of our amazing partners who worked behind the scenes to ensure that you have the best experience participating in this event and really trying out all the different protocols. And last but not least, I want to thank the ETH Global team. So I want to give a shout out to Sophia, Calvin, Nick, Delbert, Maggie, Nuno, Fred, Rory, Huichi, Anna, Moaz, Emily, Andrew, Jacob, and Liam, who do all the work behind the scenes to make these events happen and give you the best experience altogether. So thank you to everybody who made this possible. And as a quick note, we are hiring at ETH Global for our engineering team. So if you're interested in building a lot of cool ZK integrations or building a lot of cool applications that touch real consumers that already have distributions, come talk to us, head over to our careers page on our website and apply for the engineering roles that we're hiring for. Now, 8 teams presented here, and we call them our finalists. They came on and tried what they built and demoed you live what they submitted for this hackathon. And we call them our finalists because we don't want our events to feel like a competition. We don't want to have a notion of first, second, third. The goal here is to talk about interesting things and build things that help move the ecosystem forward. And as a result, we don't have a first place or a second place or a third place. Anybody who is called and considered a finalist is officially first in our event playbook. So all of these 8 teams officially came in first, and they've effectively won Scaling Ethereum 2024. And in addition to any of the prizes they would have won from our partners, for being a finalist, ETH Global will be adding in 500 USDC per member on each of these teams to thank them for building something that was super cool and doing an amazing demo here live to show everybody what's possible with Web3. But that's not it. We have a lot more things we want to do. And as a finalist for Scaling Ethereum, we're introducing the ETH Global's finalist pack. That means all the finalist teams can automatically mint the finalist Scaling Ethereum pack very soon. And that gives them an automatic way to claim a finalist hoodie, which is given and minted for just the finalist team members, and they'll be shipped to you wherever you are in the world. You will have a 10x increased faucet limit for using the ETH Global faucet, so you never have to worry about any testnet token on 14 different chains. You also get a free ticket to all 2024 Pragmas, and this will just automatically be claimable, so you can come meet us in person for any of our in-person events. And you will also get a custom developer Ledger Nano S Plus delivered to you wherever you live directly from the Ledger team. And not only that, we will also be giving you a $500 flight reimbursement to any of our in-person events this year. So you get to meet us in person at any of these 5 events that are still happening for us in 2024, and that's in Sydney, Brussels, Singapore, San Francisco, and Bangkok. So that's all what the finalists get, but there's a lot more. We want to make sure that everybody has the best experience and gets to move this place forward. So as part of just participating in this hackathon and submitting a project, if you go ahead and mint the Hacker Pack from our website with an amazing collaboration with the Public Goods Working Group, Ecosystem Working Group, and ENS Labs, every hacker who participated in scaling Ethereum will also be receiving a free ENS domain name, whether it's renewing an existing one or being able to mint a new one. And all you have to do is just go ahead to ethglobal.com/packs and mint the Hacker Pack. Soon you'll be able to see the ability to claim your ENS domain automatically, and you will be all set to receive and try out your first ENS domain. So that's it for everything on the prizes and the finalists and all the things that we're giving away. So I want to congratulate all 830 of you who participated in this event. And last but not least, what we want to do is, before we wrap up, we want to talk about what's upcoming. So we have a lot more events happening this year. So for in-person hackathons, we have ETH Global Sydney, which is next Friday, May 3rd to 5th in Sydney. Then we're going to meet all of you in Brussels on July 12th. Then in September, we're bringing people together for Singapore with ETH Global Singapore. And then San Francisco will be one of our main events of this year in October from 18th to 20th. And our last event of the year is going to be ETH Global Bangkok from November 15 to 17, complementing DEF CON. And we have a lot of async events too for all of you to participate without having to travel anywhere. And our next event is just in 2 weeks, HackFS. This will be our 4th edition of this event. And we're excited to build so many cool things that take advantage of storage and compute. So May 15th to June 7th is our async HackFS. Then we're going to do a special dedicated event with Starkware ecosystem called Stark Hacks. That's on June 13th to 26th. Then our flagship online event of this year is going to be ETH Online from August 23rd to September 13th. And those are all the events that we're doing this year. You can check out all of them right now on ethglobal.com. You can sign up for all these things and apply. And we hope to see you there in our next events, async, but also looking forward to meeting a lot of you in person over the course of the next 10 months or 8 months. So I want to thank everybody for participating in Scaling Ethereum. And with that, I want to say goodbye to all of you, and we'll see you again in Sydney next week. And if you're not joining us in Sydney, we'll see you at HackFS. So congratulations and take care, everybody. Goodbye.